So we're going to go over some important properties of continuous random variables. So x is a continuous random variable. Then we can define a cumulative distribution function, and we denote that with a capital X. Big X is the distribution, little x is a particular value we'll be putting in, and that's equal to the probability that x takes a value less than a particular value of x. Okay, so that's a well-defined quantity that we can define for discrete distributions as well, but also for discrete distributions we have something called a PMF, which gives us the probability that x is equal to x. So can we do that for a continuous distribution? Well, it turns out that the probability that x is equal to some particular value, a say, is equal to 0. So it doesn't really make sense to define probability mass function because everywhere it would just be 0. But what we can define is a probability density function, and what this actually means, a lot of people are familiar with it, but it gives us the relative probability compared to other values. So even though the probability that something is equal to a particular value is 0, it's still more likely perhaps to be closer to 0.5 than 0.1. Okay, so, and there's clusters of values that can have probabilities non-zero, and in certain regions we're more likely to get values than others, but the actual probability that we get a very specific value is 0. Okay, so we define this probability density function, little f of x, and that's just the derivative of the cumulative distribution function. Okay, now using these functions we can find certain probabilities. So the probability that our random variable x takes a value between a and b is equal to the integral from b to a of f of x dx, and that's the same thing because of how integrations work as f of b minus f of a. Okay, so that's the probability that x is less than b, that's the probability that x is less than a. We subtract that, we get the region where it's greater than a, less than b. And we can actually formalize this here, and we can say that the probability that x is equal to a is equal to the integral from a to a of f of x dx, and if both limits are the same, it's equal to 0, or the other way of thinking of this is f of a minus f of a equals 0. But yeah, just to formalise that idea. Okay, so hopefully that's simple enough. Hopefully this gives you an idea of what the probability density function is and how it relates to the cumulative distribution function, the CDF. And now when we do continue to work with continuous variables, you've got a little bit more of an understanding of what these terms mean, which should help to understand the concepts. So thank you for watching, and I hope to see you in the next video.